So, hey everybody, welcome to our virtual meetup. This is part of the like a broader series of meetups, the OpenTelemetry TLV, originally from Israel, from Tel Aviv. Due to COVID, we had the chance to actually do these meetups virtually, and have Yuri joining us from the US. The purpose of this meetup group is basically to promote OpenTelemetry and OpenTelemetry technology to the broader audience, and to get folks to know OpenTelemetry and to help them use it more extensively and easily. And obviously, having Yuri here. If you don't know Yuri already, I'll let him introduce himself in a second. But Yuri is actually one of the co-founders of this core technology, both OpenTelemetry and Jaeger, that we already heard that some of you are using. So thank you for joining us, Yuri. And today, we want to take it as an open conversation. We're going to speak with Yuri a little bit about his background and tracing in general. If any of you has like something specific that you really want us to ask, or you want us to touch, we will have time at the end to ask questions. But if you have something urgent throughout the conversation, so feel free to use the chat. We will try to facilitate it and push it forward. Just for you to know, we probably see it, but this session is recorded, and we will also upload it to the different medias afterwards. So without further ado, again, Yuri, thank you very much for joining us today and spending your time with the community and speaking with us about those topics. Maybe for those who don't know you already, if you can start by a little bit of an introduction about yourself, how you started your career, and what you're currently doing.
All right, thanks. Yeah, I'm glad to be here. Well, it's a kind of a long question then. Where I started the career, I did a PhD in machine learning at the University of Maryland, but after that I kind of dropped out of academia completely and went into industry, and I spent 15 years in the finance, in the front end trading space. And I got bored of all the product and business process work and wanted to do something more scalable and infrastructure-like. And so I joined Uber, and the focus of Uber infra team in New York specifically was observability. And so I kind of ended up in that area. Haven't really worked there before, but then I picked up one of the areas within the company that wasn't really covered, which was distributed tracing. And so we started building Jaeger, as a sort of like tracing platform, which turned out to be like later we open sourced it. Well, some of it was open sourced from the start, but some of it kind of initially were developed internally and then open sourced. And currently I left Uber about like a year or so ago. I am currently with Meta, which is formerly Facebook. I'm still doing the same kind of work, with observability and distributed tracing, just at a slightly different scale now than at Uber.
Yeah, obviously, and we will touch on most of these stations, so to speak. If you can share a little bit, you mentioned that when you joined Uber, they already had like observability team, and that was top of mind. But if you can share a little bit, what was the motivation back then, and how things looked like? Why you even got into tracing, and how you thought to take this route? Was it something new to you, or there was already a technology that you saw outside and you decided to embrace?
It was pretty new to me, although maybe like sometime later I realized that I did work with something that was very much like distributed tracing back at Morgan Stanley, where we had like a company providing that tool which would allow us to trace requests, but it wasn't called distributed tracing, so it didn't click to me originally. And yeah, at Uber, the observability team was very small in New York, and they were primarily focused on the metrics system, because I think on the kind of on the week I joined, they essentially switched over from the old system, which was based on kind of Postgres database, some of the Postgres was like an outage at Uber wide outage the same weekend that I joined, and then metric system also kind of was just switched over from what's it called, like basically it was statsd based system. I forgot the name. Then yeah, so they switched to something that was based on Cassandra, much more scalable, and then eventually that became M3DB, which is kind of now is open source system. So that area was kind of pretty well covered. I didn't need to go into that, and so as I was like one of the most senior engineers on the team, I started looking for a new area, and like login was also kind of covered, but distributed tracing wasn't, but there was a definitely interest in distributed tracing because Uber was just beginning the services journey. It had like, I think when I joined, it was about like 200 to 300 microservices in the company, and there was a massive rewrite in progress of the former monoliths. And they also had some kind of distributed, not like it wasn't completely distributed, but it was a tracing system in the Python space specifically, which very much looked like distributed system, except that it didn't actually do any cross-process requests because the whole system. And
I see. Go ahead. Sorry.
Yep. Yeah, and so yeah, that's how it started. There was definitely interest from sort of like engineers and different languages to be able to debug new situations that started happening because of the microservices migration. So that's why we started.
Got it. So the main motivation was, you know, production debugging, so to speak. Yeah, interesting that this is still, you know, what we see today. But by the way, before we move forward, why the name Jaeger? And did it start like from the early days, or it took some time until you know, gave it a name and there was this project internally?
Well, we kind of went through a whole number of different names, kind of brainstorming what we would call it. I think at one point there was like a name Flashlight. There are some names that are too embarrassing to name now, and some of the names were kind of taken at Uber internally, so they didn't pan out. I think like Sherlock was one of the other considerations, but there was a service already like that at Uber, and so yeah, we were kind of looking into this. Like how do you name things, right, in computer science, and so we were looking into the theme of sort of investigation, tracking, that stuff, and so Jaeger kind of came up as one of the variants and people liked it, and so we stick with it.
Nice, interesting. And did you know at this stage, like, what exactly you want to build? What was it clear, or you just, you know, you encountered problems and like, you know, step by step it ended up being Jaeger, or you had like a clear vision, you know, this is what we need to get to, this is how a tracing solution will look like, and so on?
Yeah, so there are certain things which were pretty clear from the beginning. I mean, not on the first day I started looking into space, but like after I've done some research in the industry and in the sort of like research literature as well, I figured that there are certain areas that we need to put on a roadmap and kind of build towards, right? And um, I kind of described it in our like blog post when we published Jaeger, is that originally we started with half of the system being actually Zipkin, right? Because Uber already had its own homegrown RPC system, which was generating data like in kind of Zipkin-like format, but not exactly. I've never understood why why that was format was not exactly Zipkin. Like it was a 3 format, but slightly different. But conceptually, it was very much like Zipkin, and it was already being generated in the architecture when we started. So we kind of built up a collector which was able to accept that data, and then yeah, we ran Zipkin front end essentially just to visualize stuff because we didn't have any UI resources at the time. But then eventually it became clear that first of all the format wasn't very sort of convenient, given the fact that we found so many instrumentation bugs by the people who invented that format, where they were like generating data incorrectly, and it was not because like just random bugs, but because the format was sort of like designed in a way that it was very easy to confuse what you need to put into the data, right? And so that's why it sort of and in parallel there was this like meetups with the Zipkin community where we kicked off an OpenTracing project. An OpenTracing project kind of laid out the foundation of an API which was much simpler to reason about than the Zipkin API for instrumentation. It kind of hid a bunch of this sort of like the landmines that were in Zipkin by design from the user, so that you couldn't make those mistakes in the first place. And just like overall model was slightly simpler, while actually at the same time more extensive because it support like logs or events in OpenTelemetry. And Zipkin model didn't really, well, I wouldn't say that. It did support them, but they were not like structured events. They were just like strings with timestamps, similar to just like regular application logs. So that was like one of the directions that we knew that we needed to invest from the beginning of starting Jaeger. So like we do need instrumentation. Uber had 4 languages in production. Zipkin didn't really have coverage in all those languages, or even if it had, that coverage was kind of sort of like all over the place. There was like maybe one person maintaining some library, and that library might do things differently from like a library in another language. And so we decided that, consider that like OpenTracing was starting as well, we decided that, well, let's build our own SDK, which are going to be consistent from language to language, built on the same data model and the same principles, and kind of fully supporting OpenTracing API, which was kind of evolving at the same time, but nonetheless. So that was like one thing that we kind of decided that we need to do. That was not like from the day one. It was maybe like 4 months into the project. On the day one, I think some of the features that we knew we wanted to do were sort of like tail-based sampling, the aggregation of data, so that analysis can be done not just on individual traces but in aggregates. And so those were put on the roadmap, and we worked towards them.
The motivation back then to look at tail sampling, you already knew that that the amounts of data are going to be so big that sampling is going to be an issue?
Yeah, pretty much. I mean, we were from the beginning sampling like 1 in 1,000. And besides, like as soon as you read the upper paper, that clearly says that you cannot sustain sort of like the data collection with 100% sampling. So yeah, we needed tail-based sampling.
Interesting. It sounds like you didn't really have a choice, but if you can share, like a lot of companies nowadays, they have this discussion of build versus buy. Obviously, today there are so many products out there. It sounds like back then you didn't really have something to rely on, and you had to develop something internally. But was there any discussion of like, can we maybe just not go ahead and build this entire thing and use existing vendors to cover it?
Yeah, that was, I think, pretty early in that overall movement in the industry, and so there were not that many existing vendors at the time, aside from just old vendors like New Relic. And New Relic, sort of like people had kind of varied experiences with New Relic. Some liked it, but there was also a lot of concerns with performance overhead, with like shipping all the data out of the data centers. And so we've looked at it. There was kind of not a lot of appetite to actually use that as the solution. And I don't think we had any viable other solutions besides New Relic at the time.
Got it. And we actually have an interesting question from the audience. You mentioned that Uber was already pretty mature with the metrics. So did you have any thoughts to, like, from the beginning to somehow merge it together and have some visualization all together? Because eventually you took this road of Jaeger that back then was like pretty siloed, just for traces. Didn't you think about, like, from the early beginning to have everything in one place?
Yes, we did. However, there are a couple things. One is Uber historically did not build like monitoring UIs. So for the metrics, Uber always used Grafana, and so there was literally no front end team who would actually develop some experience like that, which was like completely unified. The other like even bigger reason, like even today, after all these years, there is some work that was done by the observability teams at Uber to sort of consolidate all telemetry types into a single UI. That happens. It's not completely integrated, but to a certain degree. But the biggest challenge has always been this a lack of correlations between telemetry signals, because all the SDKs were kind of completely free form. You can log anything you want, or you need metrics with any sort of shape that you want. There's sort of like standardization efforts were very hard because of the culture and the way that microservices ecosystem has evolved. I think we like in the past couple of years, when I was there, we did make a lot of progress towards like standardization of the telemetry, so that we sort of said to people, look, if you want to use Go RPC, this is the one that we support. If you want to go on your own, there's like you're on your own. You're not going to get any sensible telemetry, or if you get it, you're not going to be able to correlate. So, but with the standard ones, we could at least provide certain shapes of telemetries. For example, like having the endpoint in the metric tag to be the same as in the span or in the log stream, right? That was a challenge, given that the sort of complete wild west of the instrumentation over there. You could never guarantee that they're the same. Even like simple things as service name were not guaranteed to be sort of consistently matched up. And so, yeah, that really kind of breaks apart your ability to provide any coherent UI experience where you can like cross-filter easily different telemetry types. This is why sort of like the efforts in OpenTelemetry on semantic conventions are very important, because they establish this sort of like, yeah, this is the way, it's always shared between telemetry signals, and that allows you to build much better data processing.
Yeah, this is interesting because it's probably still a challenge to this day. If you can share a little bit about the impact on Uber. You went on do this big project, new technology. Did it really make a difference? Did you feel that it benefited Uber?
Sure. I think tracing, people tend to think about tracing from this like debugging point of view, but tracing is really a platform for a lot of other stuff that you can do about the architecture, right? And I would say that even though there was definitely impact on certain teams from in the debugging workflows, that people successfully use tracing to sort of like improve latency and do all those things that you normally think of. But as a platform, it provided kind of a lot more capabilities to do much bigger stuff than just debugging, right? And so we've invested essentially from day one into the baggage propagation. There was a debate in the company is that like, should we do baggage propagation or context propagation as a standalone functionality, or do it as part of the tracing APIs? And we went with just doing it with the tracing APIs, because if you think about how you implement like sort of like tracing and context propagation, the amount of work is literally like 99% overlap. With tracing, you just like log a few extra data bits, but the propagation is the hard part of rolling out this part. And so the fact that we had like this reliable baggage propagation throughout the architecture was very impactful in a lot of other different projects, right? From sort of security point of view, like propagating some user identities or requester identities all the way to the storage where you can make authorization decisions, to other aspects like testing, the integration testing that was like tracking which services have been hit by the test, what kind of coverage versus production you get from integration tests. And even to the point of like something that is very specific to Uber, but there was this Uber is a company known for its like conflicts with the law, right? With those kind of regulations, and there were regulations in London specifically which said like, oh, you basically did such a poor job with like driver verifications of documents and all of that, that you need to have very clear sort of guarantees on what you release to production so that these bugs don't reach production ever again, right? And tracing actually played a huge role in that by actually just understanding what the business flows are, specifically related to like some of the things which were in those regulations, and then building infrastructure to keep them all like running and do the validations at the diff level. So like if you put a pull request, the system will automatically know that yes, this pull request will affect aspects of the user behavior which are subject to that regulation and so on. It's needed these are additional legal review, right? So this is like very far from like a traditional use of distributed tracing when people think of it. But again, as a platform, it's a very powerful thing because it gives you like unique view into the architecture. One thing that Uber hasn't done, to my knowledge, still is using distributed tracing for sort of capacity planning and resource attributions, something that was very big at Google, for example.
Yeah, interesting. It sounds like you mentioned here like 3-4 business related things that were impacted by tracing, and we actually talk about it a lot. The fact that if you go full on into distributed software, eventually you have to have this infrastructure in place just to answer business questions like like compliance and testing and other things. Because of the horizontal nature of the application, you have to have this kind of infrastructure in place.
Mm-hmm.
Yeah. If you could share a little bit about, it's very niche, but the decision to open source Jaeger, was it like clear to you that you want to put it out there, or what was the motivation for the team to do it?
Yeah, this is one of those areas where you can kind of go back and forth whether this was the right decision or not. I was personally kind of a fan of open source and have never done it before joining Uber, because like in finance you don't open source anything that level that we work in. And given that the technology that we were building were in no way specific to Uber business, there were not any concerns from the business or from the like leadership about open sourcing it per se. Like just saying, yeah, like let's show the work to the world as like what we're doing, right? And so that was kind of encouraged in the early days at Uber. I think later on we kind of started to put some brakes on it and like thinking about the bigger questions like what is the impact of open source, like how much effort you're going to spend on that versus like building something internally, right? That wasn't that much of a consideration in the early days, and so when we so like OpenTracing had to be open source, obviously, right? That's the whole point of it. The first implementations of OpenTracing, well, you can't have an API without any reference implementation. And so it made sense to develop those implementations as open source as well, which we've done through the Jaeger clients. So the Jaeger clients were like almost all of them were developed completely in open source. Although there were still, I think, periods where we were just like seeding the prototypes of the SDK for a new language. Like I remember Java was probably internal for a few months until we pushed it out. Like Go was open source from the beginning. But the backend itself, yeah, like once we've started doing essentially the SDK, working on them on the open source, it kind of made sense to say, well, let's push the backend in the open source as well. Why not? There is not much like downside to doing that. And we were not really thinking at the time about, oh, let's kind of build this community, and that happened later, more kind of naturally, organically. It was not the original goal, because again, like Uber was sort of in a state of mind saying like, if we can open source it, let's open source it. Like if people don't use it, it's fine. But at least we kind of show like this is the thing we've done. If you want to use it and collaborate, great. There are some naive views as well that you can actually get help from community, which is in practice not really how you want to justify open sourcing a company, because yeah, like open source brings certainly a lot of responsibilities and overhead that it wouldn't be for internal development.
Yeah, I'm guessing you feel this overhead till this day. Being here speaking about it. Yeah. So moving more into these days, obviously tracing has been around for some time now, and there were companies went back and forth around it, and we saw some open sources and so on. But till this day, I think it's still considered somewhat of a niche technology. It's not like the common thing. If you go into just the regular company out there in the world, probably they don't have it. Why do you think this is the case, and do you feel that this is actually changing, or we are at a standstill?
Yeah, it's hard to say if it's sort of at a standstill or not without some like real data. It does feel like we are progressing a bit. There is at the same time, it does feel like there is some sort of natural resistance. For example, when we talk about like the benefits of tracing, and one of the goals of the OpenTracing project was, well, let's make this like absolutely neutral API that people can just build into their software, so that people can get better observability from that software. And that didn't really happen. I mean, there have been a lot of libraries to support like various frameworks. I've almost never seen libraries or software kind of natively supporting open tracing internally versus just like saying, oh yeah, I'm using, I don't know, Spring, and there's like a separate country project which says I'm going to integrate open tracing into Spring, right? But like open tracing was never part of Spring itself, just like natively used. And so we kind of have similar hopes for the OpenTelemetry that might be it get there. It may not, right? I don't know how that will go, because so far, like, I mean, OpenTracing had its own issues with the fact that it didn't have an actual SDK, and so just integrating an API into your software does not always guarantee that you're going to get observability, especially if you like releasing binary products like a database engine or something. Then API is not enough. You actually need some implementation, and with the open tracing approach, it was sort of very vendor-specific implementation. Right? With OpenTelemetry, you do get a standard SDK as well, and so you can actually export data. So that might change, but yeah, there is I know some companies who built open tracing into their offerings, but not enough to my taste, right? I think there's like a lot more room for that. But like there is a momentum for. I know there's a work happening in the Hadoop and HDFS systems to actually integrate open tracing natively directly into the code, so that I think that will give eventually observability to people. And so to the question of like why it's not sort of like more popular than we would hope to be, that I think is still the fact that rolling out tracing instrumentation is not a completely solved problem, right? There's like a lot of software that or like frameworks which don't have integration for tracing out of the box, and so like every time you look at certain things, you kind of have to figure out what to do, and it's not like a turnkey solution today. There's also another area that I'm spending a lot of time on, is that tracing typically is very well defined from the integration point for RPC systems. But a lot of software today is not written in RPC style. There's like messaging-based systems, there's sort of like data pipeline systems, there are things like CI/CD pipelines, which are kind of mixing all kinds of ways of communication between processes, like to the point of like, I'm just like spawn a shell script, right? And so every time you hit that sort of like new thing, you again have to solve the problem of, well, how do I instrument it? Do I have to go and write the code? And so you just don't have this turnkey solution of saying, yeah, just do this one thing, and suddenly you get this distributed tracing visibility into your whole architecture. And that sort of, I think, limits the usability of the technology, because I mean, you could push for certain parts of the architecture which are higher value to the business to have like tracing, and then you can start gaining benefits from that. But yeah, like to get it everywhere takes a lot of effort for any org that I've seen.
Yeah, definitely. That's a lot of heavy lifting, and as you mentioned, a big part of it, it's like standardization, and how many people see it as something that is stable, and everyone decided on how it should look like, and exactly about that. In the last 2 years or so, we saw so many changes. The moving from OpenTracing to OpenTelemetry. You just a few months ago. Published the sunset on the Jaeger clients, and moving to the OpenTelemetry SDKs. Where do you see the end game? Like, are we there yet? Everything is going to standardize around OpenTelemetry. Do you see more changes coming up in the horizon?
Well, I mean, I can't predict what's going to happen in 5 years. So far, there is no viable alternative to OpenTelemetry that I see. I mean, some people mentioned that there is still like using Zipkin, for example, right? So I'm sure those will linger for time being. And even though we sunset Jaeger clients, people are still going to use them for like a few years more, I'm sure, without upgrading them. Because it takes actually like for people who already invested in instrumentation, redoing an instrumentation is sort of like a big expense, and so it's not an easy value proposition to just say, oh, switch to OpenTelemetry. Hopefully, like with the OpenTracing bridge existing in OpenTelemetry, that switch might still be doable. But I'm not aware of any large scale switch yet. So that this is all in a sort of alpha stage right now. So this will require more work. Yeah, I think that
you wrote about it a bit when sunsetting on the Jaeger client, but if you can share like the motivation in your view, and what did we miss by making this change, going full on to OpenTelemetry?
Sure. Well, so when we were in the OpenTracing world, there is no alternative for us but to have Jaeger clients, because OpenTracing was just an API, right? So we had to have SDKs. And however, the sort of like what the industry I think realized is that SDKs by themselves are not a value differentiator for anyone, and all the commercial companies were spending like a lot of resources on kind of building and maintaining those, and even more resources on building and maintaining instrumentation that integrates with those SDKs. For like all the different frameworks, and so like you have New Relic like monkey patching the whole world, right? And then Datadog doing the exact same thing, like spending a lot of resources. And so there's like, why do that? Like, why not just do that? And this is kind of one of the big motivation for OpenTelemetry. Like, you can only do it once. It's good enough to serve everyone's needs. And with that in mind, it was always obvious to me that if we get to that point, there's no reason why we need to, for the similar reasons, like extend resources on maintaining like Jaeger SDKs, or non-Jaeger specific, but like OpenTracing instrumentation, which is like a 200 plus projects in OpenTelemetry, OpenTracing contrib, which were like integrating all kinds of different frameworks, right? So that's kind of all migrated now, hopefully, to OpenTelemetry. And so like, yeah, there's like resources are limited, especially for an open source project, where sort of like when Uber was actively investing in Jaeger as a platform, there was like more things we could do with the resources we had. Now that they are kind of at the maintenance stage, because they've kind of reached the point where like the platform is good enough, there are certain things which more of a like exploratory that we would like to do, but they're not necessarily sort of like necessary for steady state, and continue basically reaping benefits of what's already in there. And so Uber is not investing that much to Jaeger, and so we have limited resources with commercial support to maintain and develop further features in Jaeger clients. And at the same time, you have like this whole community working on similar things in OpenTelemetry. So that it would always made me total sense to me to just say, yeah, we're gonna cut the ties with Jaeger SDKs. They've done the work for 5 years, but there's no reason to keep them sort of like evolving in parallel with OpenTelemetry. As far as what's going to be missing, yeah, there's definitely that is the pain point, and this is why we waited sort of like for almost a year to make that announcement, which we wanted to make a year ago, because there are certain features in the Jaeger clients that are still not available in OpenTelemetry, and if they're available, they may be only in 1-2 languages, not across the board, the way it was in Jaeger, and the biggest feature is probably this remote sampling, where an SDK can receive sampling configuration from the backend and reconfigure itself, and that sampling, that mechanism, sort of like, this is something that I definitely, you were asking earlier, like what was the day one roadmap, or this was day one roadmap. I knew that I want that in the SDKs. I don't want to manage like probabilities in a hundreds of thousands of services, like with the bespoke configuration, right? That had to be centralized. So that part is sort of like, if that's missing, you don't get that configuration capabilities. And what's worse, you can't actually use the adaptive sampling that Jaeger recently rolled out finally, where it's like not only you manage it centrally, but you don't even manage it. You just like, you let the Jaeger manage the probabilities. Like the backend automatically calculates the target probabilities for all of the services and endpoints by observing the traffic. So like it's kind of a control loop type system. That is probably the biggest gap currently, I would say. There are smaller features that Jaeger SDKs have. I'm not too worried about them. Like the one feature, for example, but it's kind of also specific to the fact that Jaeger SDKs use UDP. So by default, right, you can have a RPC-based exporters, but the default exporters are UDP-based. And with UDP-based exporters, you can't have a clear visibility of packet loss. And so we've built some sort of like a basic accounting system in the protocol between like SDK and the backend, which allows you to actually get that visibility, right? So you can see that, yes, I'm like, my tracer is telling me that it submitted 10 packets, but you only get 5. So you can have that and you can go investigate. And it was like very impactful when we rolled it out at Uber. We were just like, oh, boom, we have spikes in the metrics on certain services, and we went to investigate why that is. And there's like various reasons. Sometimes it's like just the CPU is overloaded and your agent running on the host just doesn't have enough CPU slice to actually process all the UDP packets, things like that. But again, like if you are in a more RPC style exporters as the default in OpenTelemetry, that might not be an issue. So again, I'm not too worried about that. I think like OpenTelemetry SDKs don't even support UDP exporters for Jaeger in all languages, if any at all. Like I don't even know if they support in any language, to be honest. And I think that's fine. I mean, I'm not too attached to UDP at this point. I think it was early decision, which we made by looking at the metrics agent that we had already. But I can't say that it was proven by the data benchmarking that this is going to be more efficient or not. And like Tigran from Splunk did a bunch of benchmarking on the exporters efficiency, and he showed that like, yeah, like RPC exporters are just as good, even remote, like sending to remote host, not just a local host. Yeah, that's kind of yeah, I would say like I'm only concerned with the remote sampling being available in the SDKs. All other features are kind of not that critical.
Got it. And speaking a little bit about the future, obviously you don't control everything. Now it's like it's almost out of your hand. A lot of players around, but looking at the future that you see for Jaeger, is it mostly housekeeping right now, or like more extensive, important capabilities that you see on the horizon being added?
Yeah, this is very hard to say. I think it's kind of in a steady state due to essentially just the resourcing issue. We have like we've lost 2 maintainers who moved on to other projects, and so we only have 4 maintainers. We don't have a company that is officially sort of building out their Jaeger stack, even though some people, like some companies using Jaeger, but I don't see like a lot of sustained level of contributions from any company yet, which makes it challenging to kind of plan any sort of big item works. Red Hat is kind of still considering what they want to do. They have some plans with like OpenTelemetry integration. The Pavel put a PR, well not PR, but the issue with the V2 sort of Jaeger. So yeah, this is unclear to me what's going to happen. There is some work still happening. So like Logs.io have recently developed a fairly brand new feature for essentially bringing some of the APM tools visualizations into Jaeger, where you could see some of the aggregate stats directly in some sort of like a monitoring tab in the Jaeger, right? It's kind of architecturally more complicated than I would have liked it to be, because it requires you to run OpenTelemetry collector to export metrics from traces, and then run some Prometheus compatible backend to house those metrics, and then Jaeger backend can query them and sort of like use them to display trends and stats about different services and endpoints, and then drill down from those into the traces, right? So there are some discussions that work probably will continue, because the company is backing that up, and like any other developments will depend on like if someone is interested to work on it. I mean, we're happy to support like new contributors with the advice, architectural discussions and reviews. It just like there needs to be willingness to actually do the work there.
Yeah, makes sense. And speaking about implementing it nowadays, we meet a lot of teams, like the team that you had back then in Uber, observability teams or platform teams that are trying to push tracing internally, putting this technology in place, but they don't see real usage coming from the developers. Obviously, there is a lot of education to do. Do you have some tips around that? Like how do you recommend to promote it internally, and getting the eyes of the other teams on it, besides the observability team that is already invested in it?
Yeah, we just had this exact discussion at my company like the other day, right? That is still the question that everyone is trying to answer. I would say there's no like silver bullet to that, but there are certain techniques that you can use to make it more attractive. Of course, like there's sort of like basic education with talks internally or bootcamp style education. Like for example, Meta has an extensive bootcamp program where there's a certain like observability courses that we take, and so we've introduced the developers to that. But to me, the biggest way to inject trace-based analysis, there are two ways. Two aspects to that. One is it needs to be integrated with the rest of the monitoring experience. Again, I assume that we're talking about sort of like this debugging use case, right? Monitoring and debugging use case, because as I mentioned, there are like other use cases where it's sometimes actually easier to get impact from tracing than trying to sort of make it into the developer tool of choice. But if you do want that, if you have that sort of like problem in architecture and interest, then integrating with the overall monitoring experience, meaning that if you have an alert on some metric, hopefully on an SLA on that metric rather than just like some root cause alert, which you shouldn't do. Then if you can insert the link into that alert, which is like with the relevant pointer to the trace data, that is usually a very big kind of motivation for people to look at that, right? Even better if you can actually, rather than inserting the link, if you actually insert the insight that you can get from that link, right? Specifically, I mean, some of the projects that we are working on internally is like, how do you, I wouldn't say root cause, but sort of like isolate the root cause over specific workflow to specific service, right? And so how you do that automatically, because again, it requires a lot of like infrastructure to be built for that, but like we already have that. And so we kind of at the next step, okay, well, how do we enable it for the users? And specifically, like if you can run some automated analysis on let's say like on a subgroup of traces, and maybe compare it with the like behavior before, and find some insights, right? And so if as soon as you insert that into alert, I guarantee you're gonna have like a spike in adoption of tracing tools, right? It just this is the way that like most of the observability products that I've seen are kind of evolving. Like if you don't if your like tracing product sits somewhere on the sidelines and like no one, you have to know about it to go that, and even if you know about it, but you have an alert here, and in order to go to tracing, you have to go and spend like 10 minutes setting up all the filters to reproduce the same scenario that alert already knew about, like the context of the investigation, right? That is the very important part. So like, yeah, integration with the monitoring is kind of the key here, I feel. Of course, there's some like questions on capabilities, like what you can actually provide. Do you have enough like samples with traces? That is sort of like one of the other challenges that we're working on, is we just can't out of the box provide enough data collection for everyone without increasing capacity requirements a lot, and we can justify them without showing like the value proposition.
Yeah, it's an interesting dilemma because you know, as you mentioned, most of those things, you know, are alert driven or incident driven, and then you have a very limited time, and there is a question like how much information you can present to the developer, and if you have this information, and how you correlate this information. But on one end, on the other hand, it's a very, you know, good point in time to catch the user and to show him tracing. But at the same time, tracing is so powerful when you are more in a investigative mode rather than an alert mode. And over there, it might even be more complicated to get it into the developer workflow and to teach folks that they can actually utilize it. Yeah, I'm guessing this is still an open question for everyone. You touched it earlier, so maybe we don't have anything to add here, and we've been around this point over and over, but still, again, you know, this difference between tracing as a debugging in production and other things that you can do with tracing. You mentioned some. Um, I'm guessing that some of them are relevant to different companies. Do you see, like, is there anything that you recommend folks? You know, you should start from that. If you take tracing into your testing, if you take tracing into your whatever, that would make a difference.
Yeah, I don't think you can recommend it like that, because it really depends on what the pain points are in the company, and what problems people are trying to solve. Because tracing can kind of provide data to solve many different problems, and I think my recommendation would be like look for the problem first, like what are the pain points that people have, and then you would know what to focus on if you want to like apply tracing here. And it's not an easy like task to do, because if the company is large enough, then there is going to be a lot of problems, and that tracing can help with, right? And so then your next step is like, well, how do you prioritize? And I would say in this case, you probably want to pick the one that you can actually solve, because for some of the other problems, you just may not have enough infrastructure in place. Like maybe you're not collecting enough data, maybe you don't have like intelligence inferences, automatic inferences done from traces, maybe you're not collecting the right metrics, right? So like, as I mentioned, like Google has used tracing for years to very large impact for resource attribution, right? That may not be a problem for smaller companies. I don't know. I'm working, but I assume it's not going to be a problem. It really comes to when you're like at a very large scale where savings are, and like especially if you are in multiple data centers, like all kinds of problems come up with, for that scale, and the tracing provides like the data for that, right? At the smaller scale, I see most often, I think people like start with just a debugging questions and sort of like latency investigation. And you mentioned that, yeah, like alert mode is a sort of a reactive workflow. There's also proactive workflow, which is that one is interesting to me, because there's this whole uh, movement in the industry talking about SLOs and how everyone should have SLOs and
Yeah.
kind of build alerts around them. And I kind of support all of that, except the one thing that I always find challenging is that let's say you have an SLO on a latency metric of your some user workflow, like I know checkout from the app, right? And there's like a
Hmm.
or add to cart button is just like too slow and people walk away from that thing. Um, so does it make sense to have an SLO on that and have alerts based on SLO? Like maybe yes, maybe no. The reason why maybe no is because ultimately it's not like a technological decision. If your SLO suddenly started trailing to becoming slower, well, if you have all the resources in the org, then sure, you can go and optimize the flow and use tracing to do that. But you may also find out that business just doesn't care. Maybe that's not that specific SLO wasn't actually that impactful to the business line, and maybe they are focusing right now on rolling out a new product, and that's where all the resources going, right? And so
Yeah.
the whole SLO culture and observability just doesn't seem to take that part into the account. Is that even though technically you can define it as SLO, but it doesn't mean that that SLO has like absolute priority to the business, right? And so in cases where it does have priority to the business, then I think you can do a lot of stuff. You can do like all the, not just reactive debugging, but you can proactive debugging, right? This is where, so like, again, when I think big companies like Google and Facebook, they have these programs in place where if you introduce a code change into production and it's like they can see that from the canary runs that this code change causes some sort of like a big CPU increase or something like that, right? They're just going to block your change, right?
Yeah.
And similarly, there might be a trend over time where certain performance is just decreasing. And so these are the things where you have sort of like this overall org-wide programs where you track those changes long term, and you ultimately just go and create a ticket to the team. And within that ticket, you might just say, oh, and this is from the tracing data, this is exactly where you should go and fix it, right? That's going to be impactful because when people go and fix it, it's like direct impact on the bottom line on your infrastructure spend.
Yeah, yeah, definitely. Okay, so we just have like 2-3 minutes left. Maybe last question before we close this session. You are currently in Meta, which is a very unique company. Probably just, I don't know, maybe 2-3 companies in the world that are dealing with such a scale. If you could share a little bit like about the challenges that you are facing today in terms of observability, in this kind of scale, what are the challenges that you have? You mentioned that adoption is still a challenge, but are there any other unique things that in such a company you're dealing with?
Well, I think the biggest unique thing is just the scale itself, and so if you contrast it with Uber, um, we didn't have much problem at Uber to just roll out tracing and provide a certain level of out-of-the-box trace collection that people could go and use for troubleshooting. And when you have like 3 billion users, as Meta has, that amount of traffic is sort of like difficult to sample adequately so that you can have enough data for any service in the architecture. And so we're kind of trying to approach that differently and sort of like working with the bigger customers and see like, can we let's enable them and see how well they can leverage the platform to solve the problems that they have. And then meanwhile, we'll continue improving the platform capabilities, improving its efficiency and capacity along the way, because it just like takes time at the scale. You can't and we can't just throw more resources necessarily to the data. So yeah, I would say that. But besides that, there are like a whole bunch of challenges which I don't think are specific to Meta in a way with tracing, like the sort of this integration into the monitoring workflow, how you do that efficiently, how you do this sort of intelligent analysis automatically so that you can surface insights rather than just pointing people to raw data, because tracing data is super complex. It's much harder to grok for engineer than kind of just like a metric chart. right? Another thing is something that I haven't experienced at Uber, but we've seen that is I think this is the nature of business and the architecture, but there's a lot more caching going on at Meta. And so when you look at the trace, you could have like a request to the web tier, then calling out literally like hundreds of thousands of times to some caches to load the data. And if you try to visualize that, you just get like unusable data in the result, right? So that we have to come up with like creative ways of how to deal with that. I have not seen that problem anywhere else that I've seen. Like I talked to other companies or like at Uber, just like never was the problem. But here it is a problem, and so we kind of have to develop somewhat unique solutions to that to deal with that.
Yeah, makes sense. Well, we're already past our bedtime. This for some of us. I think it was like extremely interesting. This for me, Yuri. Thank you for sharing all this information and being us here today. Obviously, as I mentioned, this session is recorded, so I'm guessing there's a lot of people will see it offline and asynchronously, which is which is great. If you like, folks, we will also share, I think on the Meetup group page, some other materials for getting started. We have a bootcamp that Michael here did that might be interesting for the audience that came here today. So again, Yuri, thank you so much. Thank you for the folks that joined us live. You can see it offline as well. We will share it with everyone in the different medias. Goodbye until the next session. Thank you so much.
Great. That was fun.